So now the next question is why? Right. And this increase in concentration gives you a clue about that. Why does it go into the gel? The fact that it's in high concentration, somebody was describing it as, how were you describing it?
They get stuck in there.
As getting stuck in there, right? It's getting stuck, cannot go across, and then another one comes in, piles on top. Now you have 2, and then 3, 4, 5, and you're getting a pileup of protein in there, right? So you're having a concentration of protein as they're diffusing from the surrounding buffer, and they're getting stuck in there. What does it mean to be stuck in there? Why is it stuck? What does it tell us about the interaction between protein and the gel? That there's strong interaction, that in chemists would say there would be strong affinity between the nuclear import receptor and the gel. They have the ability to interact in a strong way so that they get stuck, but they can move, but also they can move across, right? But slow, as you were pointing out. So my list of conclusions are the nuclear import receptor, that's the specific name, right, but just generically, the nuclear import receptor can enter the gel by diffusion, can diffuse across the gel because it's not just stuck at the boundary, it's actually moving in, right? But the concentration is higher inside the gel, and that means that's because it has strong affinity for the hydrogen. Any questions on these conclusions? Good? All right. So, now let's look at another protein. So we have here what we're looking at is a protein that has a nuclear localization signal. It's not a receptor, right? A protein that is just a passenger. Let's call it a passenger. It has a signal, right? And it's a big protein. Should it be able to go by itself into the gel? No. Right? So let's do the experiment. So that's what's done here in this first graph, on the left side of the experiment. So if we take this cargo protein with the NLS, and it's fluorescently tagged so we can see it. If we add it to the chamber, after a short amount of time or a long amount of time, it just cannot enter the gel. So a protein with a signal and nothing else cannot go into the gel, cannot go into the nucleus. It needs a receptor, right? So what we're going to do in the right-hand experiment is we are going to add the fluorescently tagged cargo protein with the invisible receptor protein. The receptor protein is going to be added without any fluorescence, so it's invisible. You cannot see it, but it's present there. It's floating, it's swimming together with the cargo protein. So receptor, of course, can bind to cargo protein with the signal, right? And then see what happens. When we add the cargo protein on the chamber together with the receptor, after 20 seconds, it's beginning to enter the gel. And after a long time, it has entered quite a bit into the gel. So, a protein with a signal, by itself, by its own lonely self, cannot enter the hydrogel. But if it is attached to the import receptor, which has affinity for the gel, then it can be dragged along with it into the gel. Right. So we can say that the cargo protein cannot diffuse by itself into the hydrogel. The cargo protein will go into the gel with the help of the receptor. So the two are going to bind to each other, and the receptor has the innate ability. It was born this way. We'll talk more about this next class. But it has the characteristics that allow it to interact with the hydrogel. And in doing so, it goes through the messy stuff of the gel. All the proteins are cross-linked with each other. It can swim magically through the hydrogel. And in doing so, it can bring with it its cargo protein. And the same thing we see about the concentration because of the affinity of the receptor for the hydrogen. Where else do we have a story of a barrier that is impossible to cross unless you have the right person to open it for you? So I'm going to propose that the nuclear import receptors and export receptors act the same way by opening the seas of the hydrogel to allow for the traffic of proteins that have the right signal to move across the gel. All right? So we're going to stop here. Exam on Tuesday. Make sure to bring your handouts on Thursday because we're going to continue through this same handout on Thursday. All right? Thank you, everybody.
Oh, sorry. You know what we were talking about earlier? Yeah. It just all it does is just cleans it. It doesn't like cut up
Today's lecture, only the LDL receptor part will be in the exam. Nuclear import will be in the second exam.
Wait, no? Oh, it's fine.
Yeah, detergent.